Okay, so now this is what the homework kind of looks like. What I do is I give you numbers, and I want you to figure out, just right now, I give you a fraction. I want you to know if they can be what prime numbers can be divided into it. So I give you a problem like this, 78 over 12, and essentially what I wanted you to do is I want a tactic for reducing fractions. So I give you this whole big fraction, and I don't want you to reduce it yet. I just want you to know what numbers can help it reduce. So to help with this, I pulled up the first 5 prime numbers. Okay? So what I want them to do is use the divisibility rules that they have a copy of, or that we have a video on right now, and use them just to see if we got things that are divisible by it. So let me go through what that would look like. Let's look at 2 first. Well, we know it's divisible by 2 if they're even. So 78 is even because it ends in 8. 12 is even because it ends in 2. So therefore, both of these are even, so they can be divided by 2. Awesome. So I'm going to check the box for 2. Now, let's look at 3. Well, for 3, what I do is I take the digits. For 78, I do 7 plus 8. For 12, I do 1 plus 2. 7 plus 8 is 15. 1 plus 2 is 3. 15 is divisible by 3. 3 is divisible by 3. So therefore, both 78 and 12 are divisible by 3. Now, let's check the other ones. Let's look at 5. I know 5 works when the number either ends in a 0 or a 5. That's how I know it's divisible by 5. Well, 78 ends in an 8, and 12 ends in a 2. So neither of these are divisible by 5. So I would not select C. So now let's take a look at, let me get rid of this, 7. So let me see here. Oh man, I don't know. Well, you can have a couple different ways to figure out if it's divisible by 7. One thing you can do is figure out what you know that's close to it. See, I don't know if 78 goes into 7, but let's see here. I know 7 times 10 is 70, and 7 times 11 is 77. Oh, wait a second. So then 7 times 12 will be way bigger than 78. So therefore, 7 does not go into 78. I can use that same logic for 12. I know 1 7 is 7, and 2 7s is 14. Neither of those are 12, so 12 is not divisible by 7. So 7's a no-go. So now what I'm going to do is I'm going to check for 11. Let's use blue. So let's see here. Well, let's look at the smaller number here, because really all you need to do is check 1. So does 11 go into 12? Well, nope, because 1 11 is 11, and 2 11s is 22. Neither of those are 12, so bam. So it doesn't matter if 78 goes into 11, which it doesn't. As long as 1 doesn't go in, then I can't use it. So 11 is not a box I would check. So therefore, I'd only be checking 2 and 3. Okay, let's look at the next one. So let's see. We look at the first 5 prime numbers. 2, 3, 5, 7, 11. Let's see here. First of all, both of these, let's look at 2 first. Well, 100 is even and 40 is even. So therefore, 2 is divisible. 2 can go into 140. Now, let's look at 3. Well, I add up the digits. 1 plus 0 plus 0, and I get 1. So 100 is not divisible by 3. So I don't even need to go on, but I'll go on anyway. 40 is 4 and a 0, so I add them up. I get 4. That is also not divisible by 3, so 40 isn't divisible by 3. Okay? Oops. So I say okay. Cross out the 3. Now let's look at 5. 5 needs to end in a 5 or a 0. Well, 100 ends in a 0 and a 40 ends in a 0. So 100 and 40 are both divisible by our friend 5. Okay? Now let's look at 7. Oops. There we go. Let's look at our friend 7. So let's see. We know that 7 times 10 is 70. And let's see here. 7 times 5, if you don't remember that that's 35, you could just say, listen, half of 10 is 5, so half of 70 is 35. So now, if I went up one more to 7 times 6, I get 42, which is between, and 40 is between these two numbers. So 7 does not go into 40. Let's look at 11. Well, I know that 11s go repeat numbers. So 11, 22, 33, 44. These are all divisible by 11. 40 is between 33 and 44. So therefore 40 is not divisible by 11. So what I would select is a 2 and a 5. Both of these go into 140. Okay, there we go.